Okay, I realized something. I had turned the stream off and I realized that um, here, what we need to do is overlays installed. We don't care about results overlaid because results overlaid won't exist. We want results merged, and we can get results merged by, well, the get single. So we can get results merged by adding in another operation, which okay, so this is get merge. Data flow after overlay merge. Inputs merged. Output same thing. So that's it. That should be all. Didn't like that. Okay, so okay. Get merged. Okay, so stage output merge. Okay, overlays installed. Get merged. Okay, keyer merged. Okay. See data flow with input set. Data flow is overlay batch apply. Overlay batch apply. This should be stage equals. Okay. Merged. Here merged. So it ran that data flow. It said these don't match. So overlay apply batch. Okay, we add these inputs. Okay. Wait a minute. Oh yeah, it never calls this. So list default. Definition, data flow type. Okay, so my guess is that these are not being converted into the same things. DFML, DF types. So where's our input object? My guess is that here this is wrong. Create definition. Data flow to apply as overlay. So old definition equals definition. So create definition, new type, mouse version, typing. Does this thing have like a compare? EQ, export, export. All right. So we added a little debugging statement here that checks the equalities. So what the hell is all that? Data flow being overlaid. So what we're going to do here is we're going to try to look for discrepancies within things that look the same. So we're going to say, if so if this thing is about to return false and they have the same name, print. Okay. Object DQ other. Kubernetes job customization job name customization name. All right, yeah, so my suspicion here is that we have two things with the same name. Dig here. If name equals, oh. All right, yeah, there's my suspicion. So, two things with the same name. Okay. Okay, so what's the problem? We're not calling this thing. So first off, wait, what does this look like in the future? Async def main, async with. Okay, okay, so what do we have here? So we have a system context, inputs, architecture, orchestrator, okay. So we have the inputs, we have the architecture, and we have the orchestrator. Okay, that's the system context. Okay, so overlay batch apply. Merge these overlays into. Use this data flow to merge these overlays into this data flow and apply merged overlay to this data flow. Okay. Okay, so use this data flow. Okay. So with system context. data flow. So if we wanted to define a overlay data flow, main package overlay. So we could take the main package overlay, so we could say diff main package overlay. If you want to just combine, okay, what was it we were going to do here? DFML overlays installed. So this DFML overlays installed. So this overlays installed equals data flow dot from dict, and then we just say the main package overlay combined with a different data flow. So data flow overlays installed. So I'll just do this underscore. So this is the data flow that we're applying. All right, so effectively we're doing a merge, right? So all right, so you take your main package, you merge in your DFML overlays installed, like the underscore version of that, right? And so what is the underscore version of that? Well, it's this. Okay. So then here we'll just run on the default. We can then skip all that, and we can just run this DFML overlays installed. Okay. Okay. Okay, so overlay batch apply. Overlay batch apply is the same thing. Overlay batch apply is like the same thing. So diffml overlays installed. All right, let's append defaults to true. Okay. So we run this diffml overlays installed. All right, let's do the update autoflow equals true. I think we need to do that on the output as well. So let's do that there. So that should update that should auto generate the flow. Because remember we have this inside the data flow, we have this by origin structure which maps the input flow. And you can modify that manually if you want to. Okay, so, but then update with autoflow attempts to figure out based on the operations inputs what the flow structure should be, right? So if you update the flow structure manually, then you don't want autoflow equals true. So if you're going to update the flow structure manually, you should do it after apply overlay to data flow to be executed, if you were doing it in this case. So we'll do autoflow equals true there. Okay, so I think, okay, so data flow overlays installed. So git merge, okay, data flow after overlays my. Okay, so this basically says, so we can drop this operation dot export. So all right, so we're going to replace this. Okay, so we replaced apply overlay to data flow to be executed with get merged data flow, get merged overlay, or get data flow overlay after merge, or after merged, right? So basically we replace this thing with the other one for this DFML overlays installed, because this is going to go query just the installed overlays. So we don't care about, we only want that result of that merged, because let's see. Merged, okay. Okay, DFML overlays installed. Okay, so this is going to be, what are the default overlays? Okay, so default is this. Or let's see. The default overlay.default. Okay, so we have the default. The default is this thing. I'm not sure what these comments say right now, but we'll put them up here. Okay, so all right, so diff overlays installed. Diff mount overlays installed. Okay, so basically, so when we run dfml high level run our data flow overlay, the default. Okay, well, it's not load default anymore. We can actually just grab it directly. So df.overlays installed. Okay. So this would be await data flows class. Async with data flow as class. It's overlay. Async with overlay as overlay context. Overlay context dot apply dot overlay batch apply. All right, so now we're following the double context entry pattern. Okay, so load default. Then we grab dfml overlays installed. Okay, load default or data flow. So we can just say it is dfml overlays installed. None means apply. Okay. Okay, div overlays installed. I think this should be, because this will turn into this run is the run system context. So this is like the config class for the system context. So overlay. So you could apply the overlay before you get here and then just pass data flow with overlay equals none. Or you could, and how would you do that? Well, you would pick an overlay, or you grab this one which gives it a default install. Overlays installed. Div overlays installed. Okay. I wonder if we have any input collisions here. So div overlays installed function. Just gonna comment this out for now. We're using this overlay batch apply anyway. So if we were to do data flow as class and pass a data flow, you can't do data flow as class, but you can do system context as class. And why is that? That is because a data flow on its own is just, it has no method of execution. So you can do system context as class, but you can't do data flow as class. Let's write that down. All right, so we can do system context as class. So does that mean we can do create system context as so we should really be doing, okay, so system context as class because uh, data, but not data flow as class because data flows have no method of execution without an orchestrator. So we should switch the overlay infrastructure to support taking a system context instead of an overlay or data flow. To work with system context. Okay, so so yeah, so we should really, and we should introduce system context infrastructure. We should introduce we sh So we will introduce the system context data structure, which defines inputs, architecture, and and orchestration. Okay. This can be turned into a data flow, into a class for use for the previously called data flow as class methods, where methods are send inputs into the flow with the running system context, where methods send inputs into the running system context with origins as labeled via system context to class or as class keyword arguments. So we won't have to define the origin. It'll default to seed, so defaults to seed if not set. Okay. So this can be turned into class for use of previously called data close class where methods send inputs to the running system context with origins labeled via system keyword arguments, input objects added matching method signature definitions type hints used for auto definitions. Okay, dope. This is great. Okay, equals. So we can say DFML overlays installed. Installed DFML installed overlays equals system context as class. Okay. Okay. So create a class for calling operations within the system context as methods. Okay. All right, so we're defining the system context. I thought we did this somewhere else. Oh, down here, I guess. I swear we did this somewhere else. It must be on another branch. So architecture is architecture. Open architecture. Inputs is a list of inputs. Okay. Okay. So system context says class. Class. All right, what is this? This is an operation, run system context. Okay, run system context is this. So, all right, so we're going to create a new meta class. Base configurable meta class. Let's take a look at how this worked. Um, so a meta class defines like how the class methods work on the real class. So this is, for example, we wrap a init so that we can create the config classes in the init. Actually, we need to fix up the init signatures, and we'll do that here as well. Now that we know how to do that. So this configurable meta class. If a subclass of is configurable as pass keyword. Okay, so system space configurable. Okay, so system context as class. Okay, context as class meta class. Okay, so for create methods for each operation. All right, so we're going to create methods for each operation. So for operation instance name comma operation in self.dataflow dot self.config. Okay, self.config dataflow versions. Okay, so create method for each operation. Whoa, okay, so system context as class meta class. We're like way deep in the stack here. So, pop, 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 pop. We're gonna pop, 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 back off eventually. Okay, so system context as meta class. Okay, so this is the init. So system context as class, meta class. System context as class is an operation implementation. So let's check out operation implementation. Operation implementation. Self context config. Okay, so I think it can be an operation implementation. System context can be an operation implementation. Can we have multiple meta classes? Because base data flow object. I don't think we can have multiple meta classes because it changes the new. Okay, but we can try. Okay, so system context is class, meta class. Okay, so system context is class. So if you set the data flow on this thing, so meta class, system context as class, meta class equals this. System context as class. We'll create a config object. We'll create a config object. Okay, system context is class. Where the config object is this system context. So this system context, whatever the system context is, becomes the default. So we create a new class. I think we need the name. I think we need to be past the name. So we create a new class. Um, hmm. Hmm. Okay. System context as class. We're going to leverage this run function. We take the original system context. We create this config structure. We output an operation. You output a class. You output an operation implementation. You output an operation implementation which, when double context entryed. Okay. Aha! Yay! Okay. Here we go. So we take a system context. Where was our make config stuff? That's right, we made this handy dandy subclass method. Okay, so dot subclass. And this was for CLI commands. Okay, now what did we do in here? Make new config. So this should be its own thing. Okay, data classes. Okay, okay, let's see. This is uh, replace config. Okay, so okay, value to CLI command def subclass. Oh, I thought I took this out. Oh no, I just did a read. Okay, all right. So we're going to do this. Subclass config. Okay, so this is the general pattern. This is a mess. All right. System. Oh, oh, oh. Okay, wait a minute. So, oh, ouch. Okay. So wait a minute. So maybe we can just throw the meta class right on there. Yeah, maybe we just throw the meta class right on here. System context. Okay, on entry. Okay, validate. Uh, uh, all right, so we're gonna set valid to false for now. Wow, I really screwed up my back. Um, ouch. Okay, we're gonna set valid to false for now, because we're not using it yet, but we need to remember to have a validity check um, on the system context, because it can't be executed if it's not valid, and we can determine its validity in a static fashion. So, okay, so when you enter the system context, it will start the data flow. The orchestrator will run the data flow. Okay, I think that, yeah, no, open architecture, architecture. All right, so we know that there's the data flow is probably a component of the open architecture. There may be other metadata involved with the open architecture. So with the architecture, so um, okay. Do we know all origins for all inputs used and are all outputs is all IO declared unused or explicitly or used. Okay. So, okay, so so when you instantiate a new instance of this thing, system context, and then this is a running system context or active. So it must be valid if it's active. It wouldn't have been able to active system context. Okay. Okay. So an active system context, the system context. Active system context. Okay. So, all right, so I'm grabbing from the CLI right now, read dfml data or read dfml CLI data flow, looking around to see if we could leverage the inter methods there. So where do we intern orchestrator? Self orchestrator, run data flow. Okay, I'm looking for a read get grep async context inter within. There's no or inter async context. Okay, inter async context. Okay, so yeah, here we go. I'm like, I know that we're doing this. I know it. Okay, so looks like these all have an underscore underscore stack. Okay, so self stack. This has an underscore stack. A stack, a stack, a stack, a stack. Okay, stack, stack, stack. Self exit stack. Tests. Okay. Oh, fuck. Async helper. Okay. Mm, okay. Async exit stack. So now we're looking for previous usages of async exit stack. Uh, this is what I want. DF memory. Where is it? Wait. So this is what I'm looking for right here. Is this exec enter? Await enter. That flattens things out. Exit stack. Okay. Exit. I'm seeing if there's an, okay, there, that's what we want. Yeah, this is what we want. Okay. So I think we can just call this a close. Okay, so enter async context. System context config, system context. Okay, so system context config, system context config. Okay. Okay. Context. Active system context. Okay. Okay. So self-ten config.orchestrator. Okay. And this kicks off the data flow. Okay. Active system context. Okay. So orchestrator CTX. Okay, so parent config. This is very similar to the orchestrator itself. Orchestrator. Return self. Okay. Okay, so OCTX. Okay, so okay, so parent active this is a okay. Base flavor data flow facilitator object. Okay, so this system context thing, it has an orchestrator. It enters the orchestrator. Okay, when we want to create a new version of it, right? So we want to create a new system context, right? So here is, okay, config as defaults for new class. We'll just call it subclass. Okay, so subclass will basically take, okay, okay. So, okay, we can have this subclass method, which says, okay, what's the new class? So create a new system context, replace the config with field modifications. So effectively, just set the defaults. Okay, so effectively set the defaults. So go through the existing system context, create a field modifications object. Okay, so this is what our field modifications should look like. Data classes dot fields for field in field dot name. Okay. All right, so we want to go through and make the default factory for each field, whatever it is, in right. So this says, okay, so subclass. So we want to create a subclass of the system context. Okay, so well, what's the config? Well, the config is a system con. So by default, the system context config contains no default values, right? So this system context config up here, you must specify everything, right? So now if I want to create a new system context, right, with the um, with the values from a populated config, right? So I want to create a new class which represents a system context which can be executed, right? Then I'm going to pass a system context config. So okay, config, right? And that is the config to be used as a default value. And then we will do this. Yeah, we'll do replace config, right? Okay. Oh yeah, where'd that go? It went into base. Okay. So that should give us, okay, field name. So that should do field name and then default. Okay. Blank new class name, config, subclass. Okay, so system context dot subclass. And then we say system context config, system context config. Maybe we do system context config. Right now, system context config class for config, or let's see, defaults config as defaults for subclass. Okay, and then we pass the config. So open architecture, data flow. Okay, inputs, orchestrator. Right, okay, so we know that this thing works with the memory orchestrator. Okay, so what do we got? What do we got? I think this looks pretty good. DFML installed overlays. So now, what do we do? We say, okay, so now this functions as a plugin, right? So DFML dot overlay or system context, similar to the overlays themselves. Okay. Base entry point. We basically make another class. We'll call it div.system context. Okay. Okay, and then when we create a subclass, we'll go ahead and say we'll make it an entry point. Okay, config as defaults for subclass. Okay. Oh man, wow, something's really messed up. Okay. Great, so DFML installed overlays. So this effectively becomes a floatable plugin, just register as an entry point. So DFML installed overlays. So we should also, okay, so what happens over here? So overlay equals system context. Okay, overlay equals load default. Okay, so this is a system context base orchestrator system context. Okay, so the overlay is the system context. import system context from there for now. The overlay is the system context. Okay, if it's load default, then we're going to say dfml overlays def installed. Okay. So any system context can go here. Ooh, any system context. System context config as defaults for subclass. dfml overlays installed. Dflow equals df. How much time do I have? I don't have a lot of time. Okay. So we have an orchestrator. So we're going to use our orchestrator. Orchestrator. Serve orchestrator systems. Serve orchestrator. None. If orchestrator is none, use whatever orchestrator you want. That seems unsound. Default factory. Default factory doesn't really do what it's supposed to do anymore. Okay, so how are we going to make this ergonomic? Okay. Okay, so basically, if overlay is not none, overlay class if overlay is not none, then we want to do something specific. We want you to batch apply. We want you to apply. Okay, so we say async with overlay class as overlay. Then we say async with overlay as overlay context, and then we say overlay context apply. So then we overwrite the data flow with the new data flow as a result of the application. Okay. So let's use the orchestrator overlay class. Okay, orchestrator equals orchestrator. So that should reuse if it's already open. Okay, so wait, with overlay class orchestrator is overlay. So then over here we have orchestrator equals async orchestrator. So the orchestrator, should the orchestrator just be reentrant then? The orchestrator should probably be reentrant to do ensure switch. And that means that you can do a enter on them multiple times without screwing them up. So let's go take a look at memory. So a enter, so it will create a new it will create a new if it's not reentrant. Of that entered. If self.entered, return self. Okay. Okay. So that'll make it reentrant. So get commit df memory, make memory orchestrator reentrant. Do not reset stack and networks objects or do not reset stack if on subsequent. Entry. Okay, wait a minute. Do not reset stack. Okay, wait to remove last item until exit. Final exit. Okay. Entered equals 0. On exit, we say minus equal 1 if less than 1. If entered is, so self.entered plus equals 1 on entry, right? And then on exit, so close. So if you're 1, then do the stack. So, okay, so entered is 0. On first entry increment, if you're greater than 1, If it's not the first entry, just return. On exit, if it is the first, or if you finally get back to 0, then if you're less than 1, then close. Okay. Okay. All right. So config as defaults for subclass. And orchestrators are reentrant. Is. Yeah, I won't leave that note in case that patch that gets removed. All right, so in case that patch gets removed. Okay, so if we do this, that means dfml installed overlays. Whenever it runs, everything in the global namespace is going to access. It's going to use the same memory orchestrator. We don't want that. We want config as defaults for subclass. And as, all right. Okay. This is a little funky. So dfml installed overlays, system context config, dfml installed overlays config, architecture and orchestrator, we're close. So this thing, it's all like, I think this might turn back into a data flow. All right. So with your, so if overlay is not none, then installed overlays config. So overlay context dot apply. Okay, so this thing better have this apply operation. The apply operation should take the data flow. Okay. Okay. Okay, the apply operation should take the data flow. Overlay context. So overlay apply. So overlay apply is a callable. So we're actually going to make this a callable. No. Yeah, it's a coroutine. Overlay apply. Diff mall installed overlays config. Inputs architecture orchestrator. And this is default for subclass. Config is default for subclass. Okay, so diff install overlays config. Okay, so what if we did it like this? All right, so it would be async def apply overlays default dfml installed overlays. Right, so if we treated it like a function, then we would take a data flow. Right, I would say all right. All right, so here's the caller, here's the callee. Apply overlays dfml installed. Okay, so okay, where were we? I feel like we might be off track here. Okay, so this overlays installed, so dfml overlays installed gives us the get overlay data flow after merge. So this is the merged set. So running this dfml overlays install gives you the overlay, which is the merged set of all the other overlays. So dfml overlays installed, or no, df overlays installed. So apply dfml overlays installed. Okay, so Okay. So let's go down here. So, or no, let's go over here. Okay. So if overlay apply is not data. All right. So async with orchestrator. If overlay apply is not none. Okay. So if overlay is load default, then we say it's this default overlay. I'll be right back. Okay, so what are we really trying to do here? So we're trying to allow for people to do organizational overlays when they run the should I commands, which are on okay. Okay. Oh, maybe it's because I am standing really weird. Probably. Um, hmm. Yeah, and that's right. So we're doing this on the version command. Oh, we're doing this on the version command right now because we want to show the fact that it would default overlay. Okay. So we're doing this on the version command right now because it will default overlay. I think that there's like a lot of things that should be the same thing, and it's not clear right now which ones are. So, okay. So let's see. Time to crack another highball. All right. So what else did we learn about this? Ah, I understand now. Thank you. Thank you, Alice. Okay. All right. Fantastic. Okay, so what did I just understand? Well, we have a handy dandy comment somewhere here that says that the data flow as class should be the system context as class, yada, 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 yada. Okay, so why is that important? Because of this, the parent object on the active system context. This is critical. This is absolutely critical. Why is this absolutely critical? Because this is how we maintain. Um, this is the whole DID situation. This is how we maintain. This is how we maintain context. Okay, so active system context, parent system context, parent. All right, so the input value is of type system context. So parent, input parent, parent, parent. Or so the active system context takes parent, which is system context. System context takes parent, which is an input. The input is where the system context came from. This was critical. We forgot about this. Okay. So then what can we do? So let's try to define the CLI command as, all right, where are we over there? DFML overlay, overlay, overlay. What? Okay. 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 So version equals lambda import lib metadata version. Now that's what I call a command line interface. Um, okay. So okay, so we could auto wrap this. Let's focus on what we're actually doing. Okay, so this would be contribute CLI. So the CLI command, so when the CLI command runs, let's try to make sure it has a parent system context object. Okay, so when the CLI command runs, if not util CLI command, when it runs, okay, so when the CLI command runs, what is this thing? This thing has a parent input on the config. We're so close to something, I can feel it. Maybe not, I don't want to jinx it. Well, okay, so the parent is another so parent value is system context config. Okay. Parent definition is system context config. Okay. Okay. So parent values is the instance, the definition is the system context config. Okay. Turtles all the way down. Okay, so let's try this. So let's try this system context. So when we execute this thing, command do run. Do run. Oh, this is the init. Okay. So here we say self.system context, self.top level the CLI is the caller, and as such must represent its environment as a top. A system context. Okay. So top level system context. So self.self system context equals config equals system context config. Okay, so system context config Okay. So parent equals none. Inputs equals input. Value equal extra KWR extra config definition. Okay. Interesting. Okay, so okay. So what is the data flow that describes this thing? Well, okay, so df types, okay. Okay, so data flow definitions is, all right, so addict, so definition, new definition for definition in create definition. All right, so now we define all our new types. New type. So top level system context data flow, so new type, extra config, dict, KWRgs, dict. Tfml.util.cli.command.extra config. Okay, so definitions. Okay, to us. Command args. So command keyword args and then extra config. So extra config is used for all right, so we're going to define a couple new types. We're going to say extra config, it's optional, and then keyword arguments. And we're going to add those as inputs. All right, because this is our promised calling convention. Okay, extra config, kwrgs, right. So if you wanted to run the same thing here, top level system context, inputs, architecture equals open architecture, data flow equals data flow. All right, so how would you describe this top level system context? Well, so it has no parent. Um, well, at least we don't know about the parent, really. I mean, we could maybe create another. We could potentially traverse up, and if we wanted to, but we're not going to. Uh, um, Orchestrator. Okay, so open architecture. Okay, so then, okay, all right. So run CLI command. Output equals results. All right, so that's this do run. Mm, CLI results. Okay. Okay. So extra config kwrgs. So this would be async def. CLI command. CLI command. Okay. All right, so the results might be like union listening or any, I'm not sure what the type is. Let's see. So run CLI command. Extra config KWRs. Okay, so what does this do? Well, it says command await return await command dot do run, and then extra config equals extra config, and then star star KWRs. Right, so this will replicate. So if we ran this flow, we would end up with run CLI command. So this would be right, but it'll decorate it for us. So run CLI command takes the command, extra config, the KWRgs, and returns the results. Okay, right. So that should be the same as await do run. Await do run. Perfect. Okay, right. So it does this part, right? So by the time we're running, right, so we did do run. Okay, so extra config. Okay. Run CLI command. All right. Okay. So open architecture. Run CLI and architecture. Okay. So top level system concept. Okay. So maybe we should just say system context config. Okay. Maybe we should just say system context config. Okay. So system context config. Okay. Okay. So now, so we found the right CLI command. We run it. Orchestrator is none. Okay. So that's good. That's good. Okay, we're approaching noon here. Okay, so system context config, parent non-inputs, extra config, architecture. Okay, so now the now okay, multiple things happened here. All right, so let's commit this first. Util CLI command. And where did that go? DFML base. Oops. replace config. Yes. And default base is config. Okay. Return a new instance. Oh wait, this doesn't even have any arguments. New class config name. Field modifications. Dictster any. AKA I don't have time to go traverse all the possible type information. Okay, this is new. This is that's not the right type information, but whatever. Technically speaking. So make config. Field modifications, data classes, just data classes here. Inspect is here. Return a new instance, or return a new class object which has, or new config, return a new config class which has new field class properties. Scope, which has new field class scope field properties, which has new that which are distinct instances from the okay, class code, okay. Config base. Distinct instances from the class code field properties within the config passed in to be traits similar to the parent class. Okay. If we don't do it, make new field objects and only update within a subclass, it ends up updating the properties of the subclass or of the base class as well. Okay. Let's take a look at that. Replace config. That looks better, yeah. Replace config class.config. Okay. Okay. Build modifications. All right, so this is moving replace config, so all right, so we're moving this over here, git commit -m, so git commit -sm, util, or let's see, base, add new replace config helper, allows for creating a derived config data class. Okay, we moved create definition. This is moving, okay, git commit, oh wait, let's remove this line, where is that? All right. Diff types, move create definition. All right, I don't know what I had there, but whatever. Okay. So all right. Build modification. Okay. Active system context. Okay. right. Okay. So what do we know? Okay. Let's jump back into high level. Okay, so what do we, or no, let's jump back into Alice. Okay, so we want to run this Alice version CLI command. So, which is I think when we do system context as class, we want to do a double entry. No. Okay, so how would we apply an organizational overlay? So we're going to run define util CLI command. Okay, so maybe what we do is we run that context we just created. Okay. So system context, right, none orchestrated, none. CLI. System context config. Sanitize args. What about extra config? Args.extra config. So extra config. Args.extra config. So extra config. Extra. Okay. And the value is args command, extra config, sanitize args. Okay, run CLI command. Okay, so this is so inc for run. Orchestrator equals orchestrator. Okay. Okay. Async with. Okay. OCTX.run. Okay. All right, so here's the system context config. It's going to do this run CLI command. Okay. Default orchestrated memory. Default orchestrated. Okay, so CLI. Okay. So this is the data flow for a CLI command. So OCTX. Run. Diffmal CLI system context. Okay, diff well, CLI system context. Diff well, CLI system context. Okay, man. Okay. So if we run this, then we'll do this command to run CLI command. So if okay, so if we're a command, then or wait, do run. Otherwise, oh, otherwise, so this is our holdover, right? So this is our backwards compatibility. Backwards compatibility with old style CLI commands. And then this would be our so if this thing is a subclass of a system context, so if inspect dot is class and is subclass system context. Okay. Okay. Self.subflow. Where was that subflow? Async with self.subflow. Command as OCTX. So give me a new orchestrator context. So when I ask for a subflow, so if the command defined is a system context, here it is. Okay, here it is. Here it is. Here it is. Finally, it all comes together. Okay, so if the command defined is a system context, then we can, oh man, okay, then we can, then we can execute it like a subflow. Okay. Here, system context. Okay. 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 All right, so system context. Okay, so diff of model system CLI system context. Okay, so if we wanted to override this thing, command object. Okay, so by default, okay, so overlay keyword argument not given, use default. Okay. I might have to. I'm not sure if this is going to work out. Another hour. Ooh, I don't know if I can do this. I might have to. What is next week? Oh, wow. Holy shit. May. Where's May? Where did May go? May is gone now. It's the 26th. Okay. I should cancel this. I'm in way too deep. We are way too deep right now. Can we unroll this stack in 50 minutes? Realistically, probably not. But could we? No, 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 no. Damn. There's no way this gets done in 50 minutes. Come on, I feel like we're close. Okay, let's go for 30 more minutes. Let's go till 12:30. Oof, oof. Okay, let's go till 12:30. Okay, let's go till 12:30. All right. So here. Okay. So what do we got? So, oh man. Okay, so if Alice CLI is called, okay, so async with subfile as CTX, subfile as OCTX, sync for CTX results in OCTX.run. All right, so this acts as like a little translation layer over the old world and the new world. All right, so the new world is this fully system context-based world in the old world is this one where we lose context, right? We always maintain context. Okay, so extra config, kwargs, and CLI command. Okay, I think that sounds right. Oh, of course. Oh, fuck, okay. Okay, OCTX run. Okay. Okay, what are we looking for? Where are we? What are we looking for? Started scrolling. Lost track. Okay, so OCTX. So here we're running from within subflow. Okay. And here we'll just say all right, not sure what to do with command blank. Unknown. Unknown type. Okay. So this runs when subflow if subclass command system context. Okay. So okay, so this is the system context. So this DFML system context, DFML CLI system context, DFML CLI. System context DFML CLI. Okay. System context. Okay, so parent none. Architecture is this run CLI command. Orchestrator is none. Okay. Orchestrator should be ready. Ready. Tour. All right, the orchestrator is the memory orchestrator. Okay. I'm just going to cancel this. There's no way I can figure this out. Oh man, this hurts. Okay, so, all right, postpone the meeting. Okay, system context. Okay, okay, so we preserve the context. Okay, now that we've preserved the context, orchestrator run. Okay, so subfile. How do we preserve this overlay situation? How do we preserve the overlay situation? How do we preserve the overlays? Well, this run CLI command. So if this runs CLI command, we don't need to do an overlay there. Okay. So system context. Okay, so we can do an overlay at the top level. This parent equals none. Diff system context DFML CLI. We can overlay this, right? In which case you could do something other than this. And then if you get in here and you decide to run a sub command, right? Which is reminding me we went through something the other day, which said in here is subclass method command. Okay, so we need a solution for this. Okay, um, so command equals method, parser equals parser, method doc. CLI format class. Set defaults method parser add such method. Is subclass. Is class method is subclass. Okay. Add subs. So this is just for a shorthand definition. So we can say, okay, so if inspect and or is subclass system context. Okay. Okay, so basically, if we're sure it's a class, check if it's either a old thing or a new thing, right? So either a command or system context. If it is a system context, so okay. So organizational overlay. Okay, so on startup of a CLI, we're going to load all of the default organizational overlays. So on startup of, so here, so we do not explicitly set overlays. Um, hmm. Oh, here. Okay, here it is. We need to treat it like we treat log. Oh, that's right. Okay, that's right. Okay, so we need to treat this like we treat log. Okay, command config overlay. Required false. Default equals none. Okay. So the overlays to apply before running. The overlay data flow to run before running the overlay for the top level system context. Okay, there we go. Finally. Okay. Okay, so the overlay for the top level system context. That's right. So this dash overlay. All right, so let's go ahead and remove overlay from here. Okay, and what are we going to do with it? Well, we're going to say overlay equals args.overlay. Okay. Okay, so now we have our system context that we want to run. All right, so here's our system context we want to run. Here's the things we pass into it. Here's the overlay. Okay, so now within this, so here we have the overlay, okay, args overlay, all right, overlay, let's call this system context. So is the overlay a data flow or is this system context? Well, the overlay is a data flow because it doesn't necessarily have a place you have to run it. No, is it a system context? It doesn't have, system context would be what we create. A system context would be what we create to run the overlay because the system context is what gets executed. Okay. Not necessarily, I don't know. Okay, so log command arg. Add overlay argument. Oops, overlay. All right, so here's the overlay command. Why is this? All right. All right, so overlay argument if it's not already added. Required files. Okay. Okay, so okay, so we needed to fix this up to make it the same. So basically, we're going to do a check. So first off the bat, when we get into this run CLI command, make sure we have a class. If we do have a class, check if it's a subclass of a command. If it's a subclass of a command, do the legacy stuff. If it's a system context, do the new stuff, right? So if we're doing a system context, then we're going to create a subflow within which we'll run the system context. Um, and so we should be able to use our, we should be able to, um, so if it's a system context, um, then, okay, system context. So here, overlay, CLI, Alice, version, system context, Alice, CLI version. Okay, parent is none. Oh, ouch, ouch. Ooh. Okay, so parent is none. Structure data file. Def, get Alice version. All right, orchestrated memory orchestrator. Okay, so yeah, so this one, for instance, yeah, so we by default say executed in the memory orchestrator, right? So if you use the memory orchestrator, I know you're going to be able to call import lib metadata with this operation implementation I'm providing you, right? If you use something else, this flow is not guaranteed to work, right? Okay, you better overlay it with whatever the hell you want to make sure that that implementation can be instantiated if you're going to pick another orchestrator, right? But this one will work. So that's the point. This is a valid system context. So how we map that? I'm not sure. We'll have to get into this dependency information, of course. So so in this case, we would say, let's get version op. And what we could say op op multi-output is false because we're doing auto def, or multi-output is false because we're doing auto def, and it'll set that for us. But what we care about is, what do we care about here? Oh, output. Stage equals stage.output. Right, so this will say, treat this get Alice version as an output operation, right? So this is it's just a function, but when we instantiate it within a data flow, within a system context, we say treat it as an output operation, right? So our output operations, all of our output operations are going to be callable as methods. So, okay, so how does this thing know what to execute now? So basically, what does it say? Default. Does it need the deployment environment? Does it need the deployment environment? Get Alice version. Okay, system. This is the calling convention, but we have another whole thing about the output. What is the output is sort of the data flows class methods. There's almost like another calling convention within it to retrieve the outputs. So there's like the primary call, and then there's a secondary call to get the outputs rather than a return value, because there's no return value per se, because all of this is asynchronous, right? So, okay, maybe that's helpful. So let's think like Alice, right? So we're thinking in parallel. Okay, we start the flow. We would like to know, yeah, we start the flow. So we come in, we run Alice version, and by default, okay, actually, wait a minute. By default, we're going to say load default. Load installed. Load installed overlay. Default equals apply installed overlays. All right, so this would be, says DFML overlaid install is DFML apply overlays installed default. Apply default installed. Apply installed overlays. Okay, apply installed overlays. All right. So we're thinking like Alice. Think like Alice. We come into the CLI. We say default is apply installed overlays. Okay, so that's going to get thrown into here with load default. Load default is, oh wait, oops. It's this. That's apply installed overlays. It's not this. Default overlay installed is this truly is okay. The data flow which grabs the overlays that are installed. So, overlays installed. Okay, so apply installed overlays. So this is gonna, okay, so this will say apply installed overlays. So that when it comes in here and does the execution of the system context, it will say overlay equals args overlay. Great. Okay. To do add rest of sanitized data into as inputs in case flow wants them. Okay. So we run diff. Okay. Here's the run. Overlay, overlay. Okay, util data. This one doesn't import CLI. I hope none of this shit imports the util CLI because that would be an unfortunate circular dependency. Okay, so this may be able to import run, which would be fantastic. Base. This is a little dangerous here. High level run. Okay. So overlay. Run a system context. Okay. So okay, so what I think happens here is no, okay, we need to remove this comment. Okay. Okay, so where's Alice? System context. We're so close. What is it? It's so hard to know what you don't know. Um, I think it's the deployment, quite honestly. I think this is what we're missing. I think what we need is we need a input. I think maybe we need like a, oh, maybe we should have what the output is. Maybe we add what the output is as an input. Yeah, maybe we have something that's like, if you want this output, run this flow. Okay, so if you want this output, run this flow. So if you want Alice version. So if I want some output data, I need to run any operations that produce that. We want this version as an output, results to be as version, then we need to run all operations. The operation which produces Alice version as an output operation. Okay. All right. So in that case, what does it look like over here? Maybe we say outputs. Okay, so outputs. Okay, so if you want this output, run this thing. So we want, so we want semantic version. Okay. All right, this is just to help me because Vim will highlight it. All right, hopefully that makes me see it. Okay, so we want to grab semantic version. Ding, 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 ding. Okay, so this version system context. Okay. All right, so we have to remember to set that on run and after overlay. Okay, so we want to grab semantic version. Look for types whose lineage is derived from that. If there is no output or operation which outputs a derived or direct type, raise invalid. So we are going to overlay. Okay, so we will overlay a system context, or we will overlay so I'll skip version. So maybe if we say CLI result. So maybe these things are looking for CLI result. So versions and okay, so maybe we have maybe we know that all CLI commands must accept an input in. Okay, so for a system context to be used as a CLI command, we will overlay with an output operation which we will overlay with an output operation which returns a single result within util.command. So command. Okay, I have to go. For system, we check if that this flow should produce a result for the CLI of the CLI result data type. We can say that any we can return any, so this flow should have an operation in it which this flow should have an operation in it which returns the which when CLI result is produces CLI result and takes any via taking any valid any data uh, a single piece of data derived from semantic version. Okay, so that should enable us to do that.